Hey everyone, Morgan here. So we're doing an answer key for this new homework based on acid-base reactions. What we need to keep in mind here is the Bronsted-Lowry theory. And that is that when you have an acid, that is something that donates H pluses, okay? It's a proton donor. H plus and proton are the same thing. And bases are the proton acceptors, what's accepting the hydrogens. So in this classic reaction of HCl and NaOH, the proton donor is the HCl, the acceptor is the NaOH. Now, the net ionic equation is H plus OH minus gives me H2O. See, that came from this being a strong acid, which is fully dissociated, and a strong base, which is fully dissociated, forming water, and we're having a couple of spectator ions left over, and the chlorides cancel and the sodiums cancel. We have H plus OH minus yields H2O. Now here, the HBr is giving up the hydrogen. It's a strong acid. What's accepting it is the NH3. So since this would be fully dissociated, it's H plus NH3, that's a weak base, okay, to give you NH4 plus. Okay. Carboxylic acids, sometimes called organic acids. This is a really important functional group. COOH is often how we type it, okay? So acetic acid, I am very likely to write as HC2H3O2 because that's the way I know the acetate ion, okay? But an organic chemist would very likely write it as CH3COOH. Those are interchangeable. You can use them either way. These two equations are the same equation, okay? We've just typed out the formula for the carboxylic acid a little bit differently. So the proton donor is acetic acid. And the proton acceptor is the KOH. Let's do KOH. Okay? So our net ionic is HC2H3O2, weak acid, not fully dissociated, plus OH minus, that makes H2O, and acetate ion. There you go. Okay, so now we have some others here, carbonates, phosphates, sulfates, that can all be proton acceptors. They can all be basic, okay? Carbonated happens pretty often, okay? Hydroxides, same thing, okay? So here we have NH4Cl plus CaOH sub 2. Now, the proton donor is the NH4Cl. I know the acceptor is going to be the calcium hydroxide because it's got hydroxide. Now, this is basically dissociated. NH4 plus and Cl minus and Ca2 plus and 2OH minus. So what we're looking at here is going to be ammonium NH4 plus reacting with hydroxide. The hydroxide picks up the hydrogen, becomes water, and leaves NH3 behind. Down here I've got sulfuric acid, which is a strong acid. That's going to be the proton donor, H2SO4. So the barium carbonate, that is going to be what is going to accept. Truly, it's just the carbonate that's accepting it, but barium carbonate's not terribly soluble, so it's associated. Plus, now we've got some hydrogens here, H plus from the sulfuric. Okay, now that's going to form H2O. That's going to form CO2 out of the carbonate and the BaSO4. Okay, we need 2 of these for that to work. So dissociated because it's a strong acid. This one and this one we're going to say associated because they are not terribly soluble. This is really, really insoluble, in fact. Okay, let's go over here. Now, the proton donor is the acid, H3PO4. The calcium hydrogen carbonate is going to be the acceptor. So this is pretty soluble. So we have HCO3 minus, which is going to accept the hydrogens, plus H3PO4, okay, to give us. So we're going to get phosphate PO4 3 minus. We're going to get some waters off of that and a CO2. When you have carbonates, bicarbonates, okay, you're going to end up getting carbon dioxide forming. All right. Na2S plus H2O. Okay, who's going to give up a hydrogen? That's going to be the water. Who's going to accept it? The Na2S. So really what we have here is S2 minus reacting with water. It's going to make H2S, which is actually going to bubble away as a gas, plus OH minus. So I'm going to have to put a 2 there. I'm going to have to put a 2 there. Okay. Here I've got acetic acid. I can write it the other way if I want to. And I have the calcium phosphate. So this is not terribly soluble. Okay, that's a weak acid, so it's not going to dissociate. So I think what we're going to see is Ca3, PO4 sub 2, reacting with H, C2H3, O2. Okay. Now, we're going to get acetate ion for sure. Now, the calcium, that is probably going to be floating around. There might be some solubility issues here. I actually don't have a table in front of me. I'm not remembering. Okay. So now I'm going to get waters. Okay. It's an acid-base reaction. Okay. Now this phosphate here, PO4 3 minus. Okay. A little bit of a trickier one. Okay, with what's going on here. If I want to think of it a slightly different way, I think it's reasonable to think that I could just get Ca, C2H3O2 sub 2, and H3PO4 because that's a weak acid. Okay? So I'd have to review my solubility, but I think that's a much more likely set of products. Okay. Proton donor here again is the acetic. The acceptor is the NaHCO3. That's just vinegar and baking soda. You could even try that at home. Net ionic equation. HCO3 minus, sodium salts are very soluble, plus H, C2H3O2. I'm going to get a water, I'm going to get a CO2, and I'm going to get some acetate. Okay. Here, HCl, anytime I have a strong acid, that's the proton donor. Na2CO3, I'm going to dissociate because, you know, sodium salt. CO3 2 minus plus the H plus from the hydrogen. Hydrochloric acid is a strong acid. H2O and CO2, I need to put a 2 there to balance it. Okay. Now, these are some slightly different species, but very popular with the AP exam, like dimethylamine. There's actually a lone pair on that nitrogen, and that's going to be good for accepting hydrogens. So the proton donor here is actually water. The acceptor is the dimethylamine. So what happens is we get CH3 sub 2 NH plus H2O. This loses a hydrogen, and we get OH minus, And then we have CH3 sub 2, NH2 with a positive sign. Here, again, water is going to be our proton donor, and H2 and NH2. It's kind of a bizarre species, that's why I picked it. It's called hydrazine. Plus the water acting as a base, so I'm going to get OH minus, and the hydrogen's going to join on over there. H2 and H3 with a plus. Okay, folks, there you go. That is that new acid-base homework for you. Hope this helps. This is Morgan signing off.